Hey everybody, welcome in that new Golaem tutorial, which will show you how to add blind data onto your characters and bring them into your Golaem motions so they can be used afterwards either at rendering, shading, or to drive an external Maya attribute. By default, Golaem only store animation which comes from the bones of the character skeleton or from the blend shapes. But in some situation, you may have some external controllers which are also animated, and you would like to store that animation along into your Golaem motion. So let's see how we can do this and maybe use it to control the shading of the character, the visibility of a mesh, or maybe anything which is external to your actual character. So my setup here is pretty simple. I've been doing a character which is just one bone, and it's an actual sphere mesh. I converted it into a Golaem character, so I mapped the bone as a root bone, and I just define the geometry, which is just one mesh, which attached the shading engine and the surface material. So that's my setup, and this is how my Golaem character looks like when I load it into the scene. Great, so far so good. Then in my scene I've got a setup which I would like to bring as blind data on my character. So let me maybe move my character slightly here. So I've been putting 3 different spheres of 3 different colors. So I've got a red sphere which is at 1, 0, 0, a green sphere which is at 0, 1, 0, blue sphere which is 0, 0, 1. So it's kind of, the position, it's represented the RGB color. 0, 0, 0 is my black sphere, 1, 1, 1 is my white sphere. And in between I've got a locator which is keyframe animated, which goes from red to green, green to blue, blue to white. And what I would like to do is have that locator animation being stored into my Golaem motion files, and use that to drive the body color of my character. So the body color of my character will be controlled by that locator animation. So every time I will change a keyframe here and save it as a GMO, that will replicate onto the body color. So let's see how we should do that. So the first thing is we need to add to the Golaem character the fact that there's a new channel of animation which will have to be taken into account when we're going to create a Golaem motion. So let's go into our Golaem character, and if we take a look at the bottom of the different panels that we have, we've got one which is closed by default that I can expand, which is called blind data. And as soon as I expand it, you can see that now I have a string attribute and I can type anything I want it into. So if you take a look at the documentation for that string, it will tell you that you can fetch any Maya node with a dot and the Maya attribute separated with comma, so you can put multiples, and everything which will be listed here will be considered as a new channel. And when we're going to export an animation, we're going to look into the scene if we can find that exact same node with the same name, that exact same attribute, and if we can find it, we'll store the raw data into the Golaem motion file format. So here, let's go into our locator. It's called control color. And what I need to change, what I need to store is the X and Y and Z. So let's change the value. So they're just going to be, the name will be displayed into the script editor. So I want to say control color, translate X, translate Y, translate Z. So I'm just going to copy this, put it into my character file, separate it with commas, and just put the right name. So X, Y, Z, translate. And that means that now we've got 3 new channels which are floating values, and those channels, if they exist when we're going to convert an animations, they're going to be created into the Golaem motions and stored. So let's save my Golaem character which has new data in it, and let's switch context and go into translating a motion. So let's close this for the moment. So what I want to do is load a motion from my character. So I'm going to select my root bone. I do load motion from selection, and if we can find into the scene, those XYZ value, we're gonna take them into account. So here I've loaded the root, loaded my load motion from selection, and I can just save this as a new clip. So I'm saving it as a new color motion clip. And just to make sure that that worked properly, what I can do is on my simulation that I have here, I'm gonna add a new motion behavior, which will allow me to play that motion that I have, so my GMO. And if I and reselect the motion behavior, it will update the interface. You may want to do this sometimes if the right name is not written here. And if I want to make sure that my animation is correct, I can go into my motion clip, press preview, and I can see, so the skeleton animation, well, I don't have any skeleton animation, so this is why I'm not seeing anything. But into the motion preview panel, I've got the BlindData parameters, and I can see that my motion here is 49 frames, and that when the motion starts, my translate X is 1 and the overs are 0, and you can see the value is changing slowly until it reached the value of white 111, which is what I keyframe my locator about. So okay, great, that data is actually stored into my motion, so that's awesome. And when I'm going to play that behavior onto my character, it will be played as well. So if I select my character in the viewport, obviously once again no skeleton animation, so nothing fancy to see. But if I go into the BlindData, I can see all the BlindData which are non-zero, so I can see XYZ, and it will probably converge to 1 at some point. Keep in mind that those values here are going to be influenced in the same way, but by what you specify into the motion behavior. So let's say here you say, the start frame of my motion behavior is, start frame is here. Let's say we want to start the animation at half of this duration. So we want to start at 45 frame. It means that now the motion which will be assigned to my characters is the frame 25 of the clip, which I guess makes sense, right? If you decide to increase the start duration of the animation, so it takes longer to activate the motion, so maybe it'll take 2 seconds to activate the motion, you'll see that the actual value here are not the exact value of the locator. There are interpolation between a 0, 0, 0 value and the full value of what you had in the locator. So we're blending in those values as well. So if you got another motion which is applied onto your characters and you make a transition from one to another, you will make a transition on those values here. So to translate, to blend in between those two motion in the correct manner, so you don't have just a completely change of value from one frame to another depending on the motion. If you don't want, obviously, if you don't want that blending to happen, you can just put your start duration to 0, and now what you have here is the exact value of what you add into your locator. So let's stick with this for now, because we don't want to blending with another motion. We want add frame free directly that those values are actually what's going to be applied onto the characters. Great, so that's awesome. But here in our situation, we'd like to bring this into the rendering. We wanted to control the actual color of that sphere at rendering time. So for now, it's not connected. That value exists. It's going to be written into the cache, but in no occasion it's going to be connected to the shading. So what we want to do is be able to connect it to the shading at some point. So if we want to connect it to the shading, we'll have to add another attribute. Well, we have to change our character file once again. So let's go into the geometry tab here. And for now, we're just saying our character as just a shading engine, and that shading engine is connected to a surface material, but there's nothing else on top of that. Here we'd like to be able to control the actual color, so we'll require to have a shading attribute, and that shading attribute will be able to drive anything into the shading graph. So let's add that shader attribute in, and obviously that shader attribute is going to be a color. So the type is not correct. We're going to change it to vector. We will be able to, well, we can change if we want the initial value, but we don't really care because it's not going to be driven by those. we're going to say it's going to be driven by a Golaem attribute. So let's provide a name here. So we're going to say that's going to be my body car color. And the name of the attribute will be, we can say, okay, the name of the attribute is going to be my body car color. And let's probably copy this name here. So let's save that. So what we've been doing, what we've been saying is, okay, our character has a shader, and that shader will be influenced by a shader attribute node, which is called body car color. So that's the name of the actual node. And the node will be fed by an attribute called my body car color attribute. Great. So how do we take this into account? Into first the shading graph. So let's go into Maya imp shade. Let's grab our color material. So that's something which has been covered plenty of different times into multiple tutorials, so I'll go super fast. But those attributes here, when rendering will start, we'll write them into the rendering way of representing attributes. So for Arnold, it's called user data, and Arnold provide shaders called AI user data, and they allow you, to grab an actual value and connect it. So here you can use vector or color. So I think I can use vector here and connect it to base color. So I'm saying, okay, I want to read the data which is of type vector, and you want to specify what's the name of the attribute, and the name of attribute is the name of the actual node here. So once again, when we're going to create a character at rendering type, we're going to create the actual geometry, and on top of that geometry, we'll store it as a user data, a vector attribute called body car color. Okay, so let's name that properly. So that's body car color, and now it drives the base color of my surface material. So let's save this. Yep, scene, BlindData scene, great. And we can provide, by the way, we can provide a default color. Let's say we want to have a white color by default. If the attribute cannot be found onto the character, it will just display a white color. Great, so now we've got a new attribute, a new shader attribute, and now we're driving that shading attribute, we're driving the actual color of our character. Awesome. So next step we need to do here is to connect that motion value with an attribute, and the attribute will have to be the attribute which will feed my actual character. So let's let me reopen that file just so it stays clear for everybody. So we've been saying, okay, there's a new attribute which will be created at render time, and that attribute is going to be controlled by an attribute name called my body car control attribute. So that needs to be a simulation attribute that you will have to specify what you want into this. So it means that in the simulation we'll have to create an attribute being attached on that character. So if I want to create a new attribute, I can right click here, add a new simulation attribute. So I'm going to expand this. And now I can specify what's going to be my attribute name. So my attribute name is going to be my body car control attribute. It's going to be a vector. And once again, I can specify what I want as random mean and max value here. So by default, it means that at simulation time, and let's provide some value there. Let's provide a 1 default value. So at simulation time, I'm having an attribute which I can drive with my behaviors and so on, that I'll have to export into my simulation cache. This has a specific name. So if it's exported into the cache, it will connect automatically to the shading attribute. The shading attribute will fetch the value, will provide that to rendering. So let's check if that's working. So I need to export my simulation. So I'm going to open the simulation exporter. I'm going to say I want to export my simulation from frame 1 to 50. And what do I export as a Golaem attribute? So for now I can see I'm exporting the ID, an entity type, an RGBPP, and I can see that I can export Golaem attributes. So I'm going to expand this panel. I can see that I get into the list my body car control attribute. So this one is required for the shading. So I have to export this. And now if I press render, so on the left is my actual sphere, on the right is my other character. Let's maybe provide a plane, because they're probably white on white, right? Here they are. So great, so that's my sphere. So let me check if it works, my attribute system. What I can do is probably provide a different value, random value here, because I've been providing exactly the same everywhere. So let's say we want to have red as our default value at frame 0. So I'm changing the random value of my Golaem attributes. Just export my cache once again. And if I render again, now I get my sphere, which is red. So my sphere is controlled by a simulation attribute. My simulation attribute right now is static. And it has a initial value of 100, which means red. So it means that it's connected and it works perfectly. So now I'll have to find a way to connect my locator animation to my shading attribute. And by the way, just a quick note, if you want to check what's the actual value of your Golaem attribute, at any time you can open the spreadsheet. The spreadsheet will show you every single character that you have in your scene. I just have one. And from the first frame, you're going to initialize your character. You'll see that that vector attribute has a 100, which is the same value than the default value we've been providing. Great. So here we've been saying at frame 0, my locator is of value red. At frame 15, it's green. At frame 30, it's blue. At frame 45, it's white. So how am I able to bring that data and connect it to my shading attribute? So I will require a behavior. So as it's a simulation attribute I want to drive, it's controlled by behaviors, and behaviors are the way to control simulation attributes. I'm going to use a channel operator behavior. So that's my, my spring. Yeah, that's my channel operator behavior. I can just drag and drop it at the same place. So what I want to do is I want to play a motion, and at the same time, I want to copy the information of my motion into my shading attribute. So those needs to be played at the same time. So the motion plays and updates the value of the BlindData, and the channel operator will read the BlindData at every frame and will copy it into the shading attribute. Great. So let's take a look at the channel behavior. So it allows us to create a new channel output. So when we've got this output, we can open the node editor so we can edit what's going on here. So we end up with a new editor, which allows us to design what we want to do for our attribute. So the first thing we need to configure is where are we going to output the whole computation we're going to do here. So we're going to output it into a Golaem attribute. So I'm going to write it into this attribute, my body car control attribute. So as it's a Golaem attribute, the way we control it with the simulation consists in putting this. This means I'm going to control my own attribute compared to controlling an attribute for another entity if you want. Attribute just tells that's an actual simulation attribute, and then you put the name of your simulation attribute. So we're saying that now everything we're going to plug into this will be written on a per frame basis per character into my body car color attribute. Great. So let's check what we have to feed this. We've got also an input. So the input is an expression, and into this expression we can put, a double value, a vector value whatsoever. Or we can put also a channel, and the channel, if we check what we have, it can be plenty of different things. We can look at plenty of informations from the characters. And one information we can actually look for is the BlindData that the character has. So I'm supposed to see my blind data here. I'm not really sure where they are. Velocity and wall space. PP attributes. Blind data value here. Yeah, okay, so if I was looking for, translate X, Y, Z, I would have figured it. So, if I, the name of my blind data is translate. So if I go into translate X, Y, Z, or push translate here and press enter, now I can see a reduction of the list. So I can see I have access to translate X, translate Y, translate Z, so I can create maybe 3 different input channels. Let's call it trans XN to say input for the translate X. I can create another one, which is going to be translate Y, and name it trans YN. Okay, and final one I need is going to be translate Z. And I'm going to rename that trans ZN. Awesome. So here I could let auto or set it up to channel. It does the same. If you just channel. If you just let it to auto, it will figure it's an actual blind data, so no problem. So what final step we need to do is we need to be able to take those 3 entries and make a vector out of it. So to do this, we're going to create a converter. So the converter allows us to take X, so 3 components, and convert it to a vector. So what's going to output from here is going to be a vector, so that's great. And what's going to be input in here will be X, Y, Z. So we're providing the X, Y, Z values. So RGB, translate X, translate Y, translate Z. And output this into a Golaem attribute. So let's see how it looks like. If we run the sim, at any time we can select the character and we can see the values of here are moving. And we can see there are the same values that what we have. So this is what we have from the animation. So we have Y and Z, which are 2.25 and 0.74. And we can see that what's get from X, Y, Z is 225 and 274. And it's being converted into a vector, and that vector is written into the shading attribute. So we are almost there. If we want to be able to render that data, great. We're gonna need to export the cache once again. So we're exporting the cache. Now that attribute is going to be driven by the sim. And it means that now that attribute is fully dynamic. So here we can see the locator is blue. So I would expect my sphere on the left to be blue. Awesome. That frame here, that locator is green. So I would expect my character to be green. In between, I'm going to suppose that it will be greenish, bluish. So in between, excellent. And if I go back to the frame 1, my character should be red. And if I go in between, it should be between green and red. Excellent. And at the end, it goes back to white. So if I render my scene, it goes back to white. Just a quick note, so that's working properly. Obviously, the rendering, the shading, the GPU viewport here is not able to evaluate that whole connection of stuff because there's a couple of things to take into account. So within the viewport here, you just take what's being evaluated from the shading graph. So this is why you're getting that black sphere, and you only have to go into rendering to actually see how it looks like at the end. So just to sum up, what we've been doing here is adding blind data on the characters. So those blind data allowed us to export stuff which were not skeleton or blend shapes based onto Golaem motion. Here that was a position of a locator, but it can be anything you want to. Then we've been pushing that blind data value into a shading attribute, into a simulation attribute. So simulation attribute allows us on a simulation basis to write anything you want into a a simulation attribute, and we use that simulation attribute to drive a shading attribute, which is then afterwards connected to the shading network to be able to drive whatsoever. So that's how you control a shading attribute based on anything, based on any animation within Maya. But obviously, if you want, you can also drive a visibility. So rather than using a vector, you can use a floating shading attribute, and if you name it is visible, please check the documentation for per asset visibility. It means that you can use simulation or whatsoever you want to drive the asset visibility, or you can use it to drive external objects from outside of the simulation cache. Now the simulation cache has been exported, we can use the cache output node to redrive some stuff from Maya. So hopefully that makes sense, and see you into the next video.